This content is produced by PASS the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. The easiest way to create a siding problem is to treat every gap as wasted space. At an exterior wall, some space is deliberate. Clearance above grade keeps vulnerable materials away from sustained moisture. Penetration behind the siding gives a fastener useful anchorage. Movement space keeps a material such as vinyl from being clamped when temperature changes its length. Those are three different jobs, and the field mistake is usually mixing them together. I want you to hold on to one central idea. A good siding installation must drain, stay attached, and move where the system requires movement. Drainage depends on clearances, laps, and flashing. Attachment depends on the correct fastener path and penetration. Movement depends on the specific cladding system and its approved installation details. When I separate those three functions, the numbers stop feeling random. I use a simple memory pattern for the verified clearance and water-resistive barrier numbers in this lesson. It is the rule of 2, 4, and 6. This is only a memory aid for the specific items I am about to connect to it. It is not a universal siding formula, and it is not a substitute for product instructions. 2 inches connects to two situations at the base of a wall. Wood siding and sheathing need at least 2 inches of vertical clearance above concrete steps, porch slabs, patio slabs, and similar paved surfaces exposed to weather. A stucco weep-screed also needs at least 2 inches above paved areas. 2 inches also belongs to the minimum horizontal lap of the water-resistive barrier, with the upper layer over the lower layer. 4 inches belongs to the stucco weep-screed above earth. The corrosion-resistant screed is placed at or below the foundation plate line, and its drainage edge must remain at least 4 inches above the soil. 6 inches belongs to wood above earth. Wood siding, sheathing, and exterior wall framing need at least 6 inches of clearance from exposed earth. 6 inches also belongs to the minimum overlap at vertical joints in the water-resistive barrier. So the memory line is simple. 2 over paving and 2 for the horizontal paper lap. 4 for the stucco screed over earth. 6 for wood over earth and 6 for the vertical paper lap. I do not force every fact into that pattern. I use it only where the source-backed rules actually fit. Now I want to separate wood clearance from stucco clearance, because those two are easy to blend together under pressure. For wood siding, wood sheathing, and exterior wall framing, the minimum clearance above exposed earth is 6 inches. Above concrete steps, porch slabs, patio slabs, and similar horizontal surfaces exposed to weather, the minimum is 2 inches. The field supervision point is to check the finished condition, not only the rough condition. A measurement that works before paving, soil, mulch, or a planter is installed may disappear after the surrounding work is complete. For stucco, the reference point is the weep-screed. The screed must be corrosion-resistant and located at or below the foundation plate line. It must remain at least 4 inches above earth or 2 inches above paved areas. The water-resistive barrier laps over the attachment flange, and the exterior lath terminates on that flange. That sequence allows water reaching the drainage plane to reach the screed instead of being trapped behind a reversed layer. Imagine a hypothetical project where the stucco crew leaves the correct clearance above rough grade. Later, landscaping raises the soil until it covers the screed. The original measurement may have been correct when it was documented, but the finished wall no longer has the required separation or an open drainage edge. The practical response is not to argue about which crew touched it last. The practical response is to restore the final condition before closeout. That example is why I treat grade coordination as part of siding supervision. The cladding installer cannot control every later trade, but the general B contractor can coordinate elevations, inspect the final perimeter, and document the condition before it becomes difficult to see. Polypropylene, insulated vinyl, and vinyl claddings also require at least 6 inches of clearance from the ground, and at least 1/2 inch from adjacent surfaces under the rules summarized in the research report. That is another reason not to assume that every product follows the wood or stucco number. Material matters, location matters, and the controlling installation requirements matter. The water-resistive barrier is a drainage layer, not a decorative sheet hidden behind siding. Its joints have to shed water in the same direction. Gravity is already trying to move it. Horizontal courses are applied with the upper layer lapped over the lower layer by at least 2 inches. Vertical joints are lapped by at least 6 inches. Approved corrosion-resistant flashing is also installed shingle-fashion, so water is directed to the exterior instead of into the wall cavity. I picture fish scales. Each upper scale covers the edge of the scale below it, so water glides across the outside. Turn one scale backward, and it becomes a little scoop. The same idea applies to paper and flashing. An upward-facing edge can catch water and send it behind the drainage plane. Flashing is required at the locations identified in the source summary, including exterior window and door openings, wall and roof intersections, and continuously above projecting wood trim. The word continuously matters above projecting trim. A short piece that protects only the middle does not protect the full projection. Where continuous flashing is required, sealant is not the same component and does not erase the need for the flashing. The sequence also matters. A crew can install every named material and still create a bad drainage path if the layers are reversed. I look from top to bottom and ask one practical question. If water gets behind the siding, can it keep moving down and out without meeting an exposed upper edge? That question does not replace the approved detail, but it is an excellent field check against a reverse lap. Fastener penetration is a different problem from surface clearance. The clearance numbers describe where the cladding starts or stops. Penetration describes how far the fastener enters the supporting wood. For vinyl siding installed over wood or wood structural panel sheathing, fasteners must penetrate at least 1 1/4 inches into the sheathing and framing combined. If a fastener passes fully through the sheathing, its end must extend at least 1/4 inch beyond the opposite face. For vertical or horizontal wood siding, fasteners must penetrate at least 1 1/2 inches into studs and wood sheathing combined, or into blocking. That is deeper than the minimum stated for vinyl siding, so I keep the two materials separate in my memory. There are 2 checks here. First, is the fastener long enough and placed so the required penetration is achieved? Second, is the siding face being held in the manner required by that product? Those checks are related, but they are not identical. A common mental trap is to hear that vinyl needs movement and then assume the fastener can be loose in the wall. That is wrong. The shank still needs the required penetration. The movement happens at the siding connection in the manner established by the product system, while the fastener remains properly anchored in the supporting material. The opposite trap is to focus only on embedment and clamp the siding face as though every cladding were rigid wood. The research report emphasizes that polymer cladding changes dimension with temperature. The panel must be able to move as its approved system intends. A fastener can have enough penetration and still be installed incorrectly at the face. Expansion gaps need careful language because this is where product-specific instructions matter most. The research report supports the general movement principle for vinyl and other polymer claddings, but it also sets a clear teaching boundary. Exact clearances vary by material, manufacturer, and applicable code. I do not turn one brand's end gap, butt joint detail, or nailing head spacing into a universal California number. I picture vinyl siding as a long curtain hanging from a track rather than a rigid board glued to the wall. The fasteners provide support, but the elongated attachment slots allow controlled lateral movement when the product is installed according to its instructions. The point of that picture is not to create a new rule. It is to remember why a vinyl panel should not be mechanically trapped. Suppose a hypothetical crew installs vinyl on a cool morning and drives every fastener hard against the nailing flange. Later, the wall warms in direct sun. If the product cannot move as designed, the expanding panel can bow or ripple. That outcome does not prove the exact cause on every project, but clamped movement is a condition worth checking against the approved installation instructions. Butt joints deserve the same discipline. Wood siding, fiber cement siding, vinyl siding, and other systems do not share one universal butt joint gap or treatment. Some details rely on joint flashing, some on trim or accessories, and some on product-specific spacing. I verify the selected product, the approved installation instructions, the plans, and any applicable code requirement instead of applying a remembered gap from a different material. That is the main distinction I want you to keep. Grade clearance is a code-based separation from earth or paving. Fastener penetration is anchorage into supporting wood. Expansion allowance is a product and assembly movement detail. The words all describe space, but the spaces serve different functions. Trim is where drainage, attachment, and movement often meet in one small area. Projecting wood trim requires continuous flashing above it. Window and door openings need flashing integrated with the water-resistive barrier. Wall and roof intersections also need approved corrosion-resistant flashing. Each of those locations interrupts the broad wall surface, so the field condition has to reconnect the drainage path around the interruption. Consider a hypothetical remodel where a crew installs a projecting wood band and plans to rely on a bead of exterior sealant across the top. If the required continuous flashing is missing, the sealant does not create the same shingle-fashion path behind the siding. Sealant may be part of an approved detail, but it should not be used as a substitute for a flashing component the detail requires. I also look at sequencing before the siding hides the work. The best time to correct a reverse lap or missing flashing is while the water-resistive barrier is visible. After siding and trim are complete, the same correction can require removal, reinstallation, and schedule loss. This is a supervision issue as much as an installation issue. The clean field question is simple. What layer catches water? What layer covers its upper edge? And where does the water exit? If the answer jumps backward into the wall, the sequence needs attention. Siding work also brings two safety controls that are specific enough to memorize. A ladder jack scaffold platform may not be more than 16 feet above the ground. No more than 2 employees may occupy the platform. The supporting ladders must be Type 1, Type 1A, or Type 1AA duty rated, and job-built ladders are prohibited for this use. A personal fall arrest system does not make the ladder jack height limit disappear. The platform system itself has a maximum permitted height. I keep the equipment limit separate from any other fall protection requirement that may also apply. For fiber cement siding, cutting out doors with a handheld circular saw requires a vacuum dust collection system attached to the tool. The system must provide the airflow recommended by the manufacturer and use a filter with at least 99% collection efficiency. The important supervision distinction is engineering control versus personal protective equipment. A disposable mask by itself is not the same as capturing dust at the saw. The source-backed requirement identified for this task is the vacuum dust collection system. Other protective measures may also apply to the actual exposure and work plan, but they do not justify omitting the specified collection control. I would stop the cut if the saw is throwing a visible cloud and the required collection system is missing or not functioning. Production pressure does not change the control. The correction is to use the proper tool setup and verify that the collection system matches the manufacturer's airflow requirement and filter efficiency. I want to finish the technical part with a field supervision sequence that ties the lesson together. Before cladding covers the wall, I check the water-resistive barrier laps and the flashing sequence. The upper layer goes over the lower layer. Horizontal laps are at least 2 inches. Vertical joints are at least 6 inches. Flashing remains continuous where required, including above projecting wood trim. At the base, I identify the material before I reach for a number. Wood above earth is 6 inches. Wood above paved surfaces is 2 inches. A stucco weep screed above earth is 4 inches. The screed above paving is 2 inches. I measure the finish condition and account for later soil, mulch, paving, and trim work. During fastening, I separate length from face condition. Vinyl fasteners need at least 1 1/4 inches of penetration into the sheathing and framing combined, with the through-sheathing condition handled as specified. Wood siding fasteners need at least 1 1/2 inches into studs and sheathing combined or blocking. Then I verify that the face connection follows the selected product's approved installation method. At joints and terminations, I do not borrow an expansion gap from another material. I verify the product instructions, plans, and applicable code. That is especially important at butt joints, corners, channels, windows, doors, and trim, where several systems meet. For safety, I keep ladder jack platforms at or below 16 feet, limit occupancy to 2 employees, use only the permitted ladder duty ratings, and reject job-built ladders. For outdoor circular saw cutting of fiber cement, I verify the required vacuum dust collection system, manufacturer recommended airflow, and a filter efficiency of at least 99%. The memory pattern still helps. 2, 4, and 6 organizes the core clearance and lap numbers. But the larger memory connection is drain, attach, and move. Drain with correct clearance, laps, flashing, and an open weep edge. Attach with proper penetration into supporting wood. Move according to the cladding system instead of inventing one universal expansion gap. I made an audio practice quiz specifically for the siding, clearances, fasteners, expansion gaps, flashing, and safety points in this episode. It is audio-based, the questions are read aloud, and you answer by tapping, which makes it practical when you're studying while driving, working, or otherwise on the go. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about anything I covered. I read those questions and they help me see where a rule needs a clearer explanation. Subscribe so you can stay on track through every episode until you get your license. I know you are fitting this study time around real work and real responsibilities, and I am building each lesson to help you keep moving forward.